Okay, so question 6 is organic chemistry. What is the mechanism of a Grignard reaction? So I've heard people pronounce it Grignard, Grignard. I like Grignard. Grignard reaction. So for this reaction, it is an organometallic. There's only one T in metallic. Organometallic chemical reaction where an alkyl magnesium halide. So the alkyl magnesium halide is known as our Grignard reagent. And basically it is like the carbon group that you want to add. So it can pretty much be anything, any R group you want. So it is added to a carbonyl group. So if you don't remember, carbonyl groups are like aldehydes or ketones, and they pretty much contain a double bonded oxygen to a carbon. So the Grignard reagent can be added to either a carbonyl group or even an epoxide. So I'll have examples for both. So let's say we had carbonyls. So let's say we had a ketone. And then this is our Grignard reagent. It will attack at the carbonyl. And it will give us a negatively charged oxygen. So when this takes place, it adds on the R group that we wanted, and that negatively charged oxygen, I'll just show that the magnesium bromine is kind of stabilizing it. But then once we add protons, or like an acid for our workup, the negatively charged oxygen will take one of the hydrogens to form an alcohol group. To get that as our final product. So let's see what the junior tutor said. Grignard reaction is a reaction in which a ketone or aldehyde is added to the Grignard reagent or an organomagnesium halide to produce a secondary or tertiary alcohol. Okay, so the Grignard reagent acts as a base when reacted, it produces an enolate intermediate. Next, the starting ketone is produced. So here they have it deprotonating one of the hydrogens here. And then MgBr, and then H2O. Starting ketone is produced. hydride is delivered from the beta carbon of the Grignard reagent to the carbonyl carbon, hence the occurrence of the reduction reaction. So here they show Grignard reagent coming in. Yep, so they just simplified, well, not simplified, they showed all the hydrogens in one of the CH3 groups of this Grignard reagent here. And you can see the movement of the protons and electrons. So this comes and takes that. So that just pretty much shows how it can add another R group. BR OH. Yep, so this solution is correct. So there's a lot of different types of Grignard reagents. I'll just add that as well.